Hello everyone. In today's lecture we will discuss about the Doppler's shift, or you can say the Doppler's effect. In 1842, Christian Doppler described the properties of light and sound. In a paper entitled On the Colored Light of Binary Stars and Some Other Stars of the Heavens, Doppler presented his theory. According to his theory, observed frequency of wave depends on both the emitted light and on the relative speed of the source and the observer. Means that whether the source and the observer are moving towards each other, or you can say the observer is stationary and a source of light, or you can say the source of sound is moving towards the observer or away from the observer. As light is emitted from a source, the waves being emitted can be squashed or stretched along the direction of motion. For example, here in this picture, we can observe that observer is stationary and the source of sound is moving towards the observer. So the frequency is high, but the wavelength is short. But on the back side of our source, means the source of sound, the frequency is low, but the wavelength is longer. So, if a star is moving towards us, the light waves moving ahead of the star can appear to be increased in frequency or decreased in wavelength. This translates as a shift towards the blue red of the electromagnetic spectrum. Conversely, as the star moves away from us, the waves appear to be stretched, resulting in longer wavelength and wider loop to the star, like we dealt with the source of sound. For light, the shift caused by the Doppler effect are known as blue shift and red shift. The colors just speak to the direction of the shift, means whether an object is moving towards us or away from us. Here in this picture, when a star is moving away from the observer, then observer observe red shift, and when a star is moving towards the observer, then he observed the blue shift. We can use the Doppler shift formula to calculate the change in observed wavelength, and the formula is given by delta lambda is divided by lambda naught, that is equal to V by C. Here delta lambda represents the wavelength shift that we want to calculate. Lambda naught represents the wavelength of the emitted light. V is the velocity of the source, either it is moving towards us or away from us. And C is the speed of light. We need sensitive instruments called spectrograph to detect the change in wavelength due to a star's motion. The most well-known Doppler shift in astronomy triggered the idea of expanding universe. In the coming lectures, we will also discuss about the expansion of the universe and the theories related to it. This is all about this lecture where I have discussed about the Doppler shift. See you next time. Thank you so much.